flow into gratitude for this mathematical problem. Take a moment to appreciate the fact that your mind can travel somewhere no machine, no book, no classroom can physically take you. Right now, you're standing at the entrance of an idea that connects patterns hidden in numbers, shapes hidden in space, chance hidden in randomness, and motion hidden in change. Whether you solve it or not is secondary. The opportunity to think about it is already extraordinary. Now imagine this. Someone hands you a locked vault. Not a vault made of steel, a vault made of mathematics. It has no keyhole, no password, no clues. Instead, every branch of mathematics is one of its locks. You begin with something deceptively simple. The numbers from 1 to 100. At first, they look ordinary, but every number secretly carries its own fingerprint. Some have many divisors, some have few, some hide beautiful symmetries, some are prime, some are almost prime. Every number possesses a personality that mathematicians have spent centuries trying to understand. Now imagine extracting that hidden personality from every single number, then weaving all 100 personalities together into one enormous mathematical object.
That object is no longer just a list of numbers. It becomes a living landscape. From that landscape, you build a force that controls the behavior of a curve. Not a curve you draw, a curve that must discover itself. Its every movement depends on the combined influence of every number before it. As the curve begins to move, something unexpected happens. Randomness enters. 3 numbers are chosen. Nobody knows which ones. Chance is now controlling part of the problem. But even randomness is not truly random here. The selected numbers interact through hidden arithmetic relationships. Some numbers naturally cooperate. Some resist. Some unexpectedly produce enormous values. You are asked to understand not one random outcome, but the average behavior of every possible outcome at once. Before your mind settles, geometry suddenly appears. Now you are no longer thinking about numbers. You are thinking about space itself. A perfect 3-dimensional object must exist inside a sphere. Its position is not chosen freely. Its center must sit exactly on the mysterious curve created earlier. The shape and the curve are now chained together. Move one, the other moves. Nothing exists independently anymore. Then time arrives. Instead of looking at one instant, you must observe the entire journey. Every tiny movement of the curve contributes to an accumulated history. Every moment leaves a trace.
Every trace influences every future moment. You are no longer calculating. You are watching mathematics remember itself. But the problem refuses to stop growing. Now an infinite process begins. Imagine adding together infinitely many tiny pieces. Some help. Some cancel. Some almost disappear. Individually they seem insignificant. Collectively they produce something astonishing. Infinity has entered the room. Then everything freezes. A giant square of 100 by 100 numbers appears. Every position inside this enormous structure contains information about how 2 different numbers interact. Not addition. Not multiplication. Their deepest arithmetic relationship. The entire structure behaves almost like a living organism. Its hidden vibration, its strongest natural frequency, becomes another lock on the vault. Just when you think you've seen every kind of mathematics, number theory returns. This time on an almost unimaginable scale. Factorials. Thousands of prime numbers. Astronomically large quantities. Numbers far beyond anything that could ever be written on paper. Yet hidden inside those impossible giants are surprisingly elegant patterns waiting to be discovered. Then growth begins. Everything you've built so far starts evolving continuously. The evolution never jumps. It never skips. Every infinitesimal change affects the next. Like compound interest. Except the interest itself depends on the curve. Which depends on the numbers. Which depend on the arithmetic structure. Which depends on everything that came before. Finally, You are asked one last question. Among infinitely many possibilities, which choice produces the smallest possible error? Not exactly right. Not exactly wrong. Simply the best possible balance. Only then. After number theory, probability, geometry, calculus, infinite series, linear algebra, optimization, and continuous growth have all become inseparable. Are you allowed to unlock the final quantity? A single expression. One answer. The destination every previous idea has been quietly moving toward. And that is what makes this problem fascinating. It isn't testing whether you know formulas. It is asking whether you can see connections. Because every section secretly whispers hints to every other section. The arithmetic shapes the curve. The curve guides the geometry. The geometry influences the integrals. The integrals affect the optimization. The optimization depends on the matrix. The matrix reflects the arithmetic. The entire problem is one enormous feedback loop. Now, if someone truly wanted to approach a challenge like this, there are 4 completely different mindsets they could adopt. The first is the analyst's path: break the problem into independent layers, understand each one deeply, and only then reconnect them piece by piece. The second is the computational path: build algorithms that let a computer explore every structure numerically, searching for patterns that no human eye could detect directly. The third is the structural path: ignore the calculations at first and search for hidden symmetries, invariants, conservation laws, and relationships that simplify the entire architecture before attempting any computation. The fourth is the hybrid path: move back and forth between intuition and computation, using theory to guide experiments, experiments to reveal patterns, and those patterns to inspire new theory. None of these paths guarantees success. But each one reveals a different face of the same mathematical universe. Perhaps that's the real challenge. Not finding the answer, but discovering how many different ways there are to think before an answer even begins to appear.